Hi guys, this is Carlo Kechku from solveme.com, and I'm solving the UTME Mathematics 2011 questions, and this is paper type D, question number 37. We have find the derivative of sine theta over cos theta. Now sine theta over cos theta is the same thing as tan theta, but for us to be able to apply quotient rule, we need to split it as sine theta over cos theta. And one other important thing to note here, we should really have a good grasp of inverse trig functions. Like, we should know that the inverse of sine theta is equals to cosec theta. Then we know that the inverse of cos theta is equal to sec theta, and then we also know that the inverse of tan theta is cot theta, or it's usually called cotan, but we can shorten it as cot theta. So these inverse trig functions are important. We need to know them by heart. So this is quotient rule, just as I explained in the previous video. Sine theta over cos theta, we have the product rule for multiplication and the quotient rule for division. So here we can say let u be equals to sine theta, and u is equals to sine theta. So now du d theta, we have du d theta, that is, we are differentiating sine theta now, and when you differentiate sine theta, you have cos theta. I notice that people usually have a problem with differentiating these trig functions, but okay, let me just show a quick thing here. Now when we have sine here, sorry, okay, this is sine, this is sine, this is negative sine, and this is cos, and then we have negative cos. So bear in mind that whenever you differentiate sine, you're having cos. Whenever you differentiate cos, you have negative sine. Whenever you differentiate negative sine, you have negative cos, and whenever you differentiate negative cos, you have sine. Now whenever you integrate sine, you have this. Whenever you integrate cos, you have this. Whenever you integrate minus sine, you have this, and whenever you integrate cos, you have sine. So this cycle will help you to really not miss it. So whenever you differentiate sine theta, we have cos theta. So the same thing happens. V is cos theta, V is equals to cos theta, and then we still have du d theta. So now when we differentiate cos theta, let's check. When we differentiated sine, we had cos. When we differentiate cos, we have minus sine. So we're having minus sine theta. So now we can say, applying values in equation, v du dx, that's du d theta. Okay, it's going to be in a fraction. So let me initialize our fraction. So v du d theta, v is equals to cos theta. We have cos theta here. Now du dx, that is du d theta. Sorry, this is supposed to be dv. Okay, yeah, now du d theta is cos theta also. So we have cos theta, cos theta. Cos theta. Okay. Now minus u is equals sine theta. So we write sine theta, and dv d theta, whenever you say dx is d theta for this question. So dv d theta is minus sine theta. So you note the minus sine there minus sine theta. So now all divided by v squared, and we have v to be cos theta, so cos theta is the same thing as cos squared theta. So let's have it cos squared theta. Okay, that's right. Now we can resolve this. Cos theta multiplied by cos theta is cos squared theta. So we are having cos squared theta minus sine theta multiplied by minus sine theta. So we are now having minus sine squared theta. Please, we need to be careful here. Minus sine squared theta. Okay, so let's resolve the numerator first. Minus multiplied by minus is plus, so we are now going to be left with cos squared theta plus sine squared theta. Cos squared theta plus, okay, we have cos squared theta plus sine squared theta. Okay, and from our trig identities we know that cos squared theta plus sine squared theta is equals to 1. This is a noteworthy trig identity, so we should know this, that cos squared theta or cos squared x plus sine squared x is equals to 1. So we have we've finalized the numerator and it's 1, so we are now left with 1 over cos squared theta. So therefore we are having 1 over cos squared theta, that is cos squared theta, right? So now from the inverse trig functions we know that 1 over cos theta, what I wrote here is sec theta. Therefore 1 over cos squared theta is just the same thing as 1 over cos theta multiplied by 1 over cos theta, and that is the same thing as sec theta multiplied by sec theta. So sec theta times sec theta, and when we do that we are going to have sec squared theta, sec squared theta. So that becomes the solution of this. So it's important to know our inverse trig functions. It's also important for us to know how to apply quotient rule. So from the options here we have that sec squared theta is option A. So option A is the final answer. So if you have any question regarding this particular solution, you can drop it on our comment section below. But if you have any other general mathematics question, you can leave it on our website www.solve.com and it will be attended to. Thank you very much and have a nice day.